consider the following option. Payoff at I equals 1 or 6 months later is 100 multiplied by max RK minus R1. Here R1 is the 6 months rate, 6 months later, and 0, where RK is the strike price, and we assume RK equals 2. Here, we compute the price of this option with a replicating portfolio approach. So let's move to our Excel file. Here we have our Excel file, same data. And then let's make a small table. To make more space. So here, scenarios in 6 months. Scenario in 6 months. And we have two scenarios, interest rate up or interest rate down. And then interest rate is, when goes up, it is 3.39%, and go down, it is 0.95%. To make a table, and then let's track the price of 6 months bond. 6 months bond. Price of 6 months bond in 6 months later is always 100. 100 and 100. And then we have another bond, which is 1 year bond. 1 year bond. 1 year bond. The price of 1 year bond in 6 months later, we have two possibilities. When interest rate go up, the bond price, 1 year bond price is this one, $98.319284. When interest go down, the bond price go up actually, higher than this one, and then this one when interest down, this 1 year bond. And then derivative price, we are interested in derivative price, right? So derivative price. Derivative price is $100 multiplied by max of 2%, which is exercise, minus this rate, 3.39% when interest rate up, and 0. Okay, this is pay up. So 6 months later, when interest rate up, as we know, it is 0. When interest down, the price, derivative price is 0.05. So now let's make everything in terms of return. Okay. So if you invest in 6 months bond, the return from 6 months bond is return of 6 months bond. Return of the 6 months bond is, because today's 6 months bond price is this one. Okay. And this one becomes 100. So return is, this one becomes 100. So 100, 6 months bond, divided by B2 here. So the rate return is gross return 1.0087, right? Likewise, when interest down, Again, 6 months rate is the same, $100. Okay, so 6 months return is basically same. So this is again divide this one by 6 months bond price. This one, so they should be same. The 6 months bond looks like this one. If we invest in 6 months bond, $1, then 6 months later you will earn $0.0078 as an interest rate. Next, suppose you invest 1 year bond, so return 1 year bond, then today's 1 year bond is this one, and this one becomes 1 year bond is $97. So you divide this one with this one, right? So if you invest in 1 year bond today, $1, and when interest go up, bond price goes up this amount, so in 1 year you receive $0.00436 as interest rate. If 1 year bond goes up, you will of course earn higher rate, like this one. Okay, so when interest rate go down, you will earn higher return, this one. So we have too many numbers, so let's reduce the number. Like this one, so it looks much better. Now, suppose you invest X dollar over here. You invest X dollar in 6 months bond, and you invest Y dollar in 1 year bond, then you will have a portfolio. Now the value of portfolio is, of course, this one. Multiplied by this one. So you have something like this, and then let's round this one, round to make it look better. Let's round with this one. But you also invest Y dollar in 1 year bond, so plus and then you have this one, and then you have this one, and this one. Again, let's round this number to make it prettier. You have this one, and then to fix J5. Okay, so when interest rate go up, if you invest in X dollar in 6 months bond and Y dollar in 1 year bond, your portfolio value becomes this one when interest rate goes up. But then when interest rate go down, because per dollar investment, 6 months bond return is same, but now per dollar investment in longer term bond, 1 year bond, now you earn higher return. So portfolio value would be different, like this one, all right? Like this one. right? So depending on your amount of investment in X and Y, then you will have a portfolio whose value becomes either this one and this one, depending on the scenario. Depending on scenario, which means depending whether interest go up or go down, right? And our goal here is to set X and Y appropriately. We want to set X and Y or by determining the investment in 6 months bond and 1 year bond appropriate so that we want to match this portfolio value exactly same to this one. Okay, so that's our goal. So we want to decide how much to invest in 6 months bond and how much to invest in 1 year bond and to make our portfolio value same to derivative price. Here we have a table that is basically same to the Excel file we just worked on. Okay, so we have the last row, which is basically price. So let's update our Excel file. So let's make one more row here, price. Well, interest rate doesn't have a price, so it is NA. We don't need it. And 6 month bond price today is, we know this one, and 6 months bond price is this one, and 1 year bond price today is this one, $97.89, and derivative today is something we want to compute. Okay, this is our target. We want to calculate this one, and return it is not available. It is not applicable. And value of portfolio today, since you invest X dollar in 6 months bond and Y dollar in 1 year bond, and you have portfolio today, and which means that in order to have this portfolio value, what you need is just here Y. So if we invest in X dollar here, 6 months bond, Y dollar 1 year bond, you have this portfolio value, which means that the value of this portfolio today is simply X dollar plus Y dollar, because you invest X dollar in 6 months bond and Y dollar here. So this is the portfolio value. Okay. So in the end, this one and this one should be exactly same because they generate the same one. Okay. So anyway, our goal is to find an X and Y to make this one and this one same and this one and this one same. Okay. So in a complete market, the absence of arbitrage is equivalent to the existence of risk neutral measure. Okay. Here it is complete market because we can replicate derivative price with 6 months bond and 1 year bond here. So anyway, because we want to match this one over here and this one, okay, which means that we want to make this one equal to 0 and this one equals 1.05. So we have two equations, equation number 1 and we have equation number 2. We have two equations and we have two unknowns, X and Y, which means that we can solve this equation. We can solve an X and Y. So the easy way to solve this one is you can set it up. You can set up matrices such that G1.009 and then you have X, Y equal to, you want to have 0, 1.05, 5. And for this matrix, of course, we have 1.004. Now 1.009, 1.017, right? So you can do this matrix algebra. So in order to calculate x and y, you can multiply inverse matrix of this one to each side. Then you can calculate x and y. Well, it is 2 by 2 matrix, so you can easily calculate inverse matrix. In fact, in Excel, we can do this one much easier. So remember, this matrix is exactly the same to this part of the matrix. All right? So this is A, right? Let's call this is A, right? This is A. So A, X, Y equals to 0, 5, 1, 0, 5. So they are same, right? So they are the same number. So we can basically get inverse matrix of this one and multiply this one. Then you will have x and y. Let's do this one with Excel. Here, okay, so we have this matrix. So we want to get inverse matrix of this one. So here, let's calculate. Let's make more room. Let's calculate inverse matrix over here. Okay, so in matrix inverse. And you can select this 1, 2, 3, 4. And then you can, this is important, in order to get inverse matrix, you can press Control, Shift, and then Enter. Okay, Control, Shift, you push Control, Shift, and then Enter. Then you will get inverse matrix like this. Now, you want matrix, so we have get inverse matrix of this one, and then with this inverse matrix, we multiply this and this one. So we have to do matrix algebra, multiply this and this. So how to do that? This is also easy, very interesting one. So here, let's fill it. So here, so we just calculated inverse matrix of this one, which is this one. This is the inverse matrix of this one. Now we want to multiply this inverse matrix with this one to calculate x and y. We can do this one in Excel because it's 2 by 2 matrix, 2 by 1 matrix, so our answer would be 2 by 1 vector. Okay, so I select these two cells, and then I do matrix multiplication in Excel, which is mmult. And then multiply this one with this one. And again, importantly, you have to press Control, Shift, then Enter. Now this is the answer. So basically, you have to invest minus $85 in 6 months bond, and plus $85 in 1 year bond, which means that in order to replicate this derivative, what you have to do is you borrow in short-term rate and invest in long-term rate. Okay, this is very important. You short sell 6 months bond, so basically you mean you are borrowing for the next 6 months, and then you invest 1 year bond. Then if we sum this x and y, which is portfolio value, sum these two, then the portfolio value is $0.369. And because if we invest this one and this one in 6 months bond and 1 year bond, we have exactly same derivative price in each scenario. So therefore, the value of this portfolio should be exactly same to derivative price. Therefore, derivative price is this one. In order to check whether this one really replicate this one, we can easily check it. You can multiply this one and this one, right? Then we want to check whether if we multiply this one and this one, we have this one. Okay, let's check it. Let's check it. So m mult of this one, and then this one, Control Shift Enter, then we exactly same thing. So we this number and exactly same to this number. So by investing this amount in 6 months bond and 6 months in 1 year bond, and you have exactly same replication of this one and this one. So because 6 months later you have the same number in each scenario, the value of this portfolio should be exactly same to the value of these derivatives. Therefore, the value of this derivative is this one. Actually, if you can remember, this number is exactly same to the number in the previous class. So here we just did matrix algebra and we got x and y and plus x and y, and we have this derivative price.